going to look at frequency distributions, how to make them, and how to read them. Frequency distributions are tables used to organize quantitative data. You see quite a bit of raw data shown here. These are raw scores for hours of sleep for an imaginary data set. The frequency distribution is just one of several options you have for summarizing your data. Remember that raw data are data that haven't been computed or summarized or calculated in any ways yet. When looking here at the array of raw data, it can be a bit confusing. It's hard to see patterns. We don't quite know what's going on. The first thing to do when you're confronted with raw data is to look for patterns in the data and identify any key elements. Pause here and take a look at these numbers. Note anything that you think might be important about this array of numbers. Here's a few things you might have noticed. The highest number appears to be a 12, and I'm only seeing one of them here on the board. The lowest number appears to be a 3. These are going to be important numbers for us as we move forward. You might also have noticed that some of the numbers are a bit more numerous than others. For instance, I see quite a few 7s here in the data set, even though I only saw one 12 and one 3. I'm also seeing a lot of 8s here in the data set, and quite a few 9s as well. Creating a frequency distribution will help us to see these patterns more clearly, and also to note some things that aren't as clear when we're looking at the raw data. We're now ready to move through the steps in creating our frequency distribution. The first step is to identify the range. The highest value we observed was a 12. The lowest value we observed was a 3. The formula for the exclusive range is the highest value minus the lowest value in any data set. So in this case, our exclusive range is 12 minus 3, or 9. Now we can move on to step 2. When we create a frequency distribution, we like to use between 10 and 20 intervals to subsume the range of data. That means we want to have between 10 to 20 rows in the table. The reason for this is if we have fewer than 10, we're probably not giving enough information. But if we have more than 20, our table starts to look overwhelming and it doesn't do its job of summarizing things simply and easily for the viewer. One easy way to estimate the size your intervals should be is to take the range and divide it by 10. In this case, we get 9 divided by 10 equals 0.90. One thing we want to do is ensure that our intervals are intuitive or easy to use numbers that people usually count in, like 1s, 2s, 5s, 10s, 20s, 100s. 0.90 is not a number that we're used to counting in, so we're going to round that up and use 1.00 as our interval because it'll give us approximately 10 intervals without being a number that's confusing to work with. Now we're ready to create our template using our interval. The interval we chose is 1. The frequency distribution table has 2 columns. The first column is for the score or interval, and the second column is for the frequency. When using an interval of 1, we're going to call our column the score column. Anytime we use an interval that's a different range than 1, we would call this the interval column. Then you can just list your intervals going from the highest interval at the top to the lowest interval at the bottom. Because we have 1 unit intervals, I'm just going to be listing scores here. The highest score we saw was a 12, so that's going to go at the top of my table, followed by an 11, a 10, 9, 8, and so on. Notice that I'm moving down in 1 unit intervals because that's the interval we decided on. Notice that I'm showing all the scores in the intervals going from 12 down to 3 in 1 unit increments. I'm not showing any numbers above a 12 because that was the highest number in the data set. So anyone looking at my table knows that was the highest number. 13, 14, 15, 20, 100, those did not occur in the raw data. We also see that my table ends here at a 3. That indicates to us that there were no 2s, 1s, 0s, or any negative numbers in the raw data set. I've drawn in some quick guidelines to help me line up my rows across the 2 columns, and I'm going to get rid of that empty space at the bottom so my table looks cleaner. We're now ready to add the frequency column. We start by giving it a name, then we have to go back to our raw data and count how frequently 12s occurred. That means how many 12s were in the data set. Well, we already know there was only one of those because we noted that when we were looking at the raw data. We also noticed that there was only one 3. But it's hard to remember what all the data were in the raw data set, which is why we create tables like this to help us summarize. So switch back, look at the raw data, and see if you can figure out how many 11s, 10s, 9s, 8s, 7s, 6s, 5s, and 4s were in the data set so we can complete the table. This is step 4, where we organize our data so that we can fill in the frequency column of our table. Take note of how many of each number occurs. We already noted the 12s and 3s, so I'm going to start counting down to note how many 11s, then 10s, and so on appear in the dataset. I see 2 11s in our dataset, 3 10s, 4 9s, 5 8s, 4 7s, 3 6s. There are 2 5s and 1 4. I already know that there's only 1 3. Let's fill in the frequency column. We already knew there was 1 12 and 1 3. We just looked back at the data and we found 2 11s, 3 10s, 4 9s, 5 8s, 4 7s, 3 6s, 2 5s, and 1 4. If I wanted to know how many raw pieces of data were in the data set, we would call this the sample size, or n. I could find that by adding up all the numbers in the frequency column. If I add up all these frequencies, I find that there are 26 numbers in the raw data set, so our sample size is 26. By filling in the frequency column with the count of each score from the raw data, we've yielded a nice summary. I can easily see which numbers occurred more or less often in the data set. Those with the highest frequencies are the numbers that appeared the most often. The most common number that appeared in the dataset was an 8 because it occurred 5 times. But 9s and 7s were also fairly common because each of these occurred 4 times. The rarer numbers in the dataset were the ones that occurred just once. This would be 12, 4, and 3. 5, 6, 10, and 11 occurred less often than 7, 8, and 9, and more often than 3, 4, and 12. So we already have a pretty good sense of what was happening in the data set just by looking at this table. I also know that the highest score in the data set was a 12 because I don't see anything appearing that's higher than a 12 in the score column, and the lowest score in the data set was a 3 because no lower scores appear here. One thing to note is that we always show all of the intervals that appear between the highest and lowest score in the data set, even if they were empty. So let's say there had been no 10s and our frequency there had been a 0. We would still leave the row in showing the score of 10 and the frequency of 0. Why do you think this might be? It's because if we remove that section, we get an artificial appearance that numbers count from 7, 8, 9 to 11 and 12. Unless our brain notices that something's missing here, we presume that the 10 did appear in the table. So it makes more work for the brain if we delete an empty row that appears between the highest and the lowest score in the data set. So for those reasons, we do not delete any empty rows that appear within the range of raw scores. Finally, we're ready to polish our table by adding a short, clear title. Each table or graph gets numbered. We've only created one table, so this is Table 1. Notice that Table 1 does not appear in italics. Just underneath that, you can see my concise title for the table, and that title appears in italics. Hours of sleep, parentheses, n space equals space 26, end parentheses. There's no punctuation at the end here. It's always nice to give the sample size. Take a moment to consider why we emphasize leaving a space on each side of the equal sign. The reason is so that you can clearly see the symbol n as distinct from other items such as the numbers or the equal sign. Because we use a lot of complex symbols sometimes when we're doing statistics or other mathematical computations, the spaces help to ensure that we don't misinterpret or misread two symbols close together as being one symbol. That's it for construction. All that's left is for us to double check our work, the final step to anything we're doing as researchers or statisticians. Ask yourself a few questions when looking over your frequency distribution to make sure that your table is constructed correctly. Are all the raw data accounted for? We had a sample size of 26, so we should see that the total, if we sum up the frequency column, also equals 26. Otherwise, we've missed a piece of data somewhere. Does each column have the appropriate title? The first column will always be called score when you're moving in single-digit increments like we did, or interval when you're moving in multiple-digit increments. The second column will always be labeled frequency. Could the table be reconstructed to be clearer? Well, we used a small interval of 1, so we couldn't make it clearer by breaking those down into smaller intervals because 1 is already the unit being used in the raw data. That is, the raw data was counting from 3 to 4 to 5 to 6. We didn't have anything like a 4.5 or a 6.25. So we already broke our intervals down in the most conducive way to understanding these data. We also have approximately 10 intervals in our table. Remember that we want to have about 10 to 20 intervals. If when I'm done making my table, I notice I only have 4 intervals, or I have 35 intervals, that tells me I might want to start over and reconstruct my table in a way that makes the summaries easier to understand. Let's take a moment to address when to use intervals before we move on to a practice. We use intervals when our data have such a large range that if we used individual score movements like 1 to 2 and 2 to 3, we'd end up with more than approximately 20 rows of information. Let's take a look at an example. Take a look at these raw data and try to identify the highest and lowest scores in the data set to help you figure out what the range is. The highest score in the data set is 115. The lowest score is 0. So the range in this data set is equal to 115 because that's the same as the highest score, 115, minus lowest score of 0. Now remember that we want to have about 10 to 20 intervals. So to decide on the approximate interval length, we can take that range and divide it by 10. If I divide 115 by 10, I get an approximate size of each interval of 11.5. Remember our rule. We want our interval size to be something that's intuitive, a number that the brain understands easily or can count in easily. The closest to this would be 10, because our brain is used to counting 10, 20, 30, 40, 50. It's not used to counting 11.5 plus another 11.5, so on and so forth. So the appropriate interval for this data set could be 10. Another option for us would be to use 5. The reason for this is because we can also have 20 intervals. So if I did the same thing, I took my 115 and divided it by 20 to say I want a maximum of approximately 20 intervals. That gives me a score of about 5.75. Now, of course, I wouldn't want to use 5.75 as an interval because that's not a number our brain usually counts in. But we are used to counting in fives, like 5, 10, 15, 20. So our two options for interval size are 10 or 5. Try it out and see if you understand the concept. Assume that our variable is calories consumed per meal, where you notice in your data set that the highest number of calories consumed by an individual was 1,176 calories and the lowest was 0 calories. For this one, would we want our first column of the table to be a score or interval column? If you said interval because you noticed the range was pretty large here, you're correct. Let's try another one. What if our variable was number of children? We noticed the highest count of children in the dataset was 8 to one parent, and the lowest count was 0. If you said that this one should be score instead of interval because the range is small, you're also correct. Let's try a third one. Here, I'm not going to give you the high and low. I want you to try to figure it out without that information. Our third variable is annual income measured in dollars. If you noted that this should be an interval because the amount of money people make ranges widely, could be $0, could be $10,000 a year, could be $1 million a year, you're also correct. Now for this one, if we have a really large range, we might need to use really large intervals. For example, if the lowest income was $0 and the highest was $100,000, we'd probably want to use $5,000 or $10,000 intervals. If we use $5,000 intervals, we're going to get close to the 20 intervals. If we use $10,000, we're going to have approximately 10 intervals on our table. But let's say that the lowest income earned was $1 million a year, and the highest income earned in our data set was $40 million a year. Here, we might want to start our table at 1 million because nothing appears below it, and count up in increments of 1 million to 2 million. In fact, in this case, we'd want to use probably 2 million to 5 million because that would give us the appropriate number of intervals. Now you can try it out using this data set. The data here refer to the number of books individuals said they owned. You can look for a couple of things here to help you get started with your data set. First, note the sample size. That's how many pieces of raw data you have. Then, find the highest score and the lowest score to help you identify the range. Remember, the range is equal to the highest score minus the lowest score. Use the range to decide whether your first column of the table should be a score column or an interval column. Once you have that, you're ready to start constructing your own example of a frequency distribution.